We're going to look at a percent yield problem. And this one's also off your 12-3 worksheet. Now in this one, it says determine the percent yield for a reaction between 82.4 grams of rubidium and 11.6 grams of oxygen if you only get 39.7 grams of rubidium oxide produced. So the first thing you have to do, balance the equation. Same as always. So in this one, I'm going to go ahead and write down my reactants, rubidium, which is a solid, plus oxygen, remember diatomic, it's a gas. And looking at this, what type of reaction could this possibly be? Remember from predicting products? Well, if we look at this, it's probably going to be a composition, a synthesis type reaction. So we're going to get rubidium oxide. And rubidium oxide will be the solid. Now we need to go ahead and balance it. Luckily for us, it's already balanced. So let's go ahead and write down what they've given to us as far as the reactants. Now, what's produced, we're going to look at that at the end. So they told us we have 82.4 grams of rubidium. And they also tell us we have 11.6 grams of oxygen. This sure looks like a limiting reactant problem to me, which it is. Okay, we're only going to get out 39.7 grams of rubidium oxide, but we've got to figure out which thing do we use up first, the rubidium or the oxygen, before we can get to the rubidium oxide. So I'm going to have to work this out as a limiting reactant. I'm going to have to find which one. Now, and before I start deciding which one to use first, find the molar masses. So the molar mass of rubidium, straight off the periodic table, is 85.47 grams. And the molar mass of oxygen is going to be 2 times 16, so 32.00 grams. Now when I look up above, notice the coefficients are just 1 for rubidium, 1 for oxygen. And what I end up seeing here is I almost have a mole, I have over a mole of rubidium, and definitely less than a mole of the oxygen. Since their coefficients are the same, well, I'm really thinking the oxygen is going to be the limiting reagent here. So what I'm going to do is I'm going to start with and assume that oxygen is. And let's go ahead and prove that to make sure. So looking at this, I'm going to start with the oxygen. So I'm going to start with my 11.6 grams of O2. Then I need to convert that into moles of O2. So I have 1 mole of O2. This is going to be 32 grams of O2. So I get rid of the grams of O2. Now I'm going to use my balance equation to convert this into rubidium. So I'm checking for limiting reactant. 1 mole of rubidium, using the coefficients. For every 1 mole of rubidium, we need 1 mole of oxygen. Now let's convert this back to grams of rubidium. And I know there are 85.47 grams of rubidium for every 1 mole of rubidium. When I multiply that out, I get 32.98 grams of rubidium. So I have 82.4 grams. So that means oxygen is the limiting reactant here. Now, there's several ways to do these problems. You could have actually figured out how much rubidium oxide you could get from 82.4 grams of rubidium, and then try it again for the 11.6 grams of oxygen. But in my case, I just wanted to verify that it is in fact O2 is my limiting reactant. So now, let's figure out if the oxygen completely reacted, how much O2 would lead to, or how much rubidium oxide would I get out of 11.6 grams of oxygen. So I go back and do this again. So I start with my 11.6 grams of oxygen over 1. Now I'm going to convert this, instead of to rubidium, to see which one is limiting. I want to see how much rubidium oxide I get out. So just like before, 1 mole of oxygen for every 32 grams of oxygen. And this is, once again, a 1-to-1 relationship if you look at the coefficients. So now I'm seeing how much rubidium I get using the oxygen, because I know that's my limiting reactant. So 1 mole of rubidium oxide for every 1 mole, once again, I'm just looking at the coefficients, 1 and 1, of oxygen. So now I have it in terms of moles of rubidium oxide. Let's put it into grams. Well, what happens here is I'm missing the molar mass of rubidium oxide. So the molar mass of rubidium oxide, all I have to do is add these two together, all right, because that's Rb and O2. And in this case, I get 117.47 grams to 117. So I know I need 117.47 grams of rubidium oxide for every 1 mole of rubidium oxide. And this is then equal to 42.58 grams of rubidium oxide. Well, here's my problem. I want to know the percent yield. I should have gotten out, if it went to 100% completion, 42.58 grams. But I only got 39.7 grams. So in order to get the percent yield, it's going to be equal to what I actually got out, which was 39.7 grams. Divide that by what the maximum I could have gotten out, 42.58. We'll do sig figs here in a second, grams. Multiply that by 100, turn it into a percent, and I would get my percent yield as being 93.2%. And that is your answer. Once again, there are a couple different ways to do this. If you just wanted to start off and find how much rubidium oxide you would have gotten from each of those reactants, if you would have used them all up, you could have done that.